So the reason why we're doing this lesson last is because I want it to be the freshest in your brain when we take the test. This is where students have a lot of trouble, is when we connect the math that we're learning to a real world context. But that is actually how we started out. Right? Our very first piece of notes on August 25th, which seems like it was forever ago, but it was only about 3 weeks ago, is exactly what we're doing today. It'll be slightly different, and you'll see how. But remember, we talked about the number of hours in the car versus the number of miles traveled. That's a specific context that we're talking about this math in. So when I found my M, or in that case K, but it's the same thing. When I found that my M was 60, my answer wasn't just 60, it was 60 what? Miles per hour. So units are going to be a big thing when we're talking about unit rate. Okay, unit rate. So unit rate is just slope, but it's slope within a certain context in that problem. It's a comparison between two quantities where the second quantity is 1. 1. Now there's tons of ways that we can think about unit rate in the real world with stuff that we're familiar with. For example, do you guys know what minimum wage means when I say that?
How much you get?
How much I get what?
Paid.
Paid? Someone said per what? Hour. So if I get paid $16 per hour, right? And hopefully we've all heard a phrase like this before. This is a unit rate. I'm comparing two quantities, dollars and hours, and the second quantity, which is hours, is just one. $16 per 1 hour. Right? You would never get a job and they say, oh, we pay $32 every 2 hours. That's just a weird way of saying it, right? You break it down to where the second unit is just one, $16 per hour. 50 miles per hour, right? The second quantity is just one. We all listen to music. Every song has a certain kind of rhythm and tempo to it. The unit rate that's used there is something like 135 beats per minute. So if you have like a slow song, you know, it's going to be something like 80, 90 beats per minute. If you've got a fast song like EDM or, I don't know, EBK Jabo or something, you have like 135 beats per minute. It's a lot quicker. The tempo is a lot faster, right? I don't know. I don't really listen to him. But. So the two quantities are beats and minutes. The second quantity, minutes, is 135 beats in 1 minute of the song. $16 in 1 hour of work. 60 miles in 1 hour of driving. That's how I know I've got a unit rate. But if I had something like I drove 100 miles every 2 hours, would that be a unit rate? No, because the second quantity isn't what?
1.
What was it?
1.
Okay, we're doing something, so let's focus on what we're doing, okay? Because I guarantee you, when we're asking questions and you're messing around during the notes, I ain't answering anything. This is not a unit rate because the second unit is not 1, it's 2. Now this is still a rate. I can still drive 100 miles every 2 hours. But what would the unit rate be that matches this same rate? 100 miles every hour? Well, that would be someone going twice as fast. If I go 100 miles in 2 hours, how many miles can I go in 1 hour? 50 miles per hour would be the unit rate, okay? Still a rate, but the second quantity isn't 1, So it is not considered a unit rate. All right? Give me a thumbs up if that's making sense so far. Pretty straightforward, right? Yeah. Okay, and again, these are all around us. We see this all the time. If you got a nice little Prius, right? You're saving money on gas. You get good gas mileage. You say like, oh, I got 40 miles to the gallon. 40 miles per 1 gallon of gas is how much you're using, or how far you can go. Okay? So, we got an equation here. This is a test question. Okay? This is a 8-point question on the test. Is this right here? So make sure you're paying attention. Y is equal to 50x plus 100. I'm comparing two things here, and I can tell what I'm comparing based on the graph. So what are the two quantities that I'm comparing based on what my graph says? Am I talking about miles per hour here? What am I talking about?
Months and dollars.
I'm talking about the time in months. And I'm talking about the total dollars saved. Give me a thumbs up if you have a savings account. Anyone's parents hooked them up with a nice little savings account? You put your birthday, Christmas money in there. Nice. So it's a context we're familiar with. We're not always going to get context in math problems that we're familiar with, right? We talked a couple weeks ago about the trains, right? Most of us haven't been on a train, so we may not be able to directly, relate to that. But we've been in a car, we've been on a plane, we kind of know what that travel aspect looks like. Here, if you have a savings account, you'll understand what we're talking about. And even if you don't, you still probably will. What is the unit rate based on this equation? Let's look back up at the top. What's another word for unit rate? Slope. So what's the slope from this equation? 50. M is equal to 50. Now, if I wanted to make 50 into a fraction, what can I put underneath that 50? A 1. So my unit rate tells me $50 every 1 month. Thank you. Those are my units, right? Months and dollars. We will in a second. We're going to take it step by step. What does this unit rate mean in the context of this problem? Well, we're talking about a savings account, right? So if my unit rate is $50 every month, what do you think I'm talking about? I'm talking about money. Good start. This is a savings account, right? How much what'd you say? That's right. How much I'm putting away every month. I'm depositing and saving $50 every month. So there's $50 saved and deposited each month. With these problems, if we don't understand what the problem's talking about, we're not going to understand the math that we already know how to do. So there's a connection that needs to be made between the math that you're already comfortable with and the context that's going to be new to you every single problem. Anyone here get an allowance from the parents? Yeah? Okay, very nice. So in this context, right, you can say, all right, my mom gives me $100 a month to do chores around the house and walk the dogs or something like that. 50 of that I'm going to spend, I'm going to get me some Labubu's or whatever, and the other 50 I'm going to deposit it into my savings account so that I can grow my savings and have money later on, right? So I'm saving $50 every month. Now, 50 is not the only number in this equation, right? What other number do you see there? 100. Is this my slope, 100?
No.
No? What is that 100? What do we call that number that's kind of hanging off on the end?
Y.
That's my y-intercept. So my b value is 100. What do we kind of say that b stands for again? What word starts with b that we talked about? Begin. So what does this 100 mean in the context of the problem? Anyone got any ideas? You start at 100. Okay, you said what? We plot it. We're definitely going to plot it. Context of the problem. We're not talking about math. We're talking about what am I talking about with this problem? Where did this 100 come from?
How much money you got and 50's half of it.
How much money you got, and then 50 is half of it. Okay, we're on the right track. I love that thought. What did you say, Lila? How much money you start with. That's great. You start with $100 in the account. So when my mom first opened up a savings account for me when I was in like, I don't know, 9th or 10th grade or something, she opened it up and put $50 in there as kind of the starting balance because you need some money in there just to open an account. You can't have a savings account with $0 in it. So you open it up. She's like, there's $50 to start you off, and then you save your allowance every week. That's what's getting added. That would be my unit rate. Okay? So I'm starting off with $100 in the account. Let's graph this. Now, this is a little bit different because we're only looking at the top corner of my graph. Right? So if I'm looking at something like this, I'm only looking at this section of the graph right here. But again, that's what we started this unit out with. Hopefully it doesn't throw you off too bad. So here's my y-axis. I'm going to highlight it in pink. Here's my y-axis. I'm going to begin by plotting my y-intercept. So where am I going to make my first dot along that y-axis? Well, what's the b value, Billy, we just said we had? 100. So here's 100. I'm going to make my first dot right there. We begin our savings journey with that $100 in the account. Now, how many dollars is each little square worth on this y-axis here? 50. Every 2 squares is 100. So every 1 square is 50. Right? Let's fill in the blanks. 50, 100, 150, 200, 250, right? All the way up, 350, 450, 550, and 600. How many months is each box representing on the x-axis? 1. 1, 2, 3, 4, 5, 6. And again, this is what we did with our beginning lessons. We filled in all the blanks so I know kind of what I'm dealing with here. Everyone cool on how we filled those blanks in? Yeah? Okay. Everyone see how we start at the 100? We're not starting at the origin here. We're starting at 100. And how much am I depositing every single month? 50. So what I'm going to do is I'm going to rise $50 and run 1 month. Now you may be like, well, there's not 50 boxes. I'm not going to count 50 boxes of my rise. How many boxes do I need to count up?
50.
50? There's only like 10 boxes here. 1. Each box is 50. So I'm going to rise 50, run over to 1 month, and make a dot. I want to point out that this is much different than what we talked about on Friday, because on Friday, every square was worth 1 unit. But here, it's going to be different every single time. Every box might be 50, it might be 20, it might be 10. Right? But I'm going to follow this same pattern. Up 50 over 1, make a dot. Up 50 over 1, make a dot. Up 50 over 1. And we can follow that pattern again as far as we can all the way up. And that gives me all my points. Does that look like a straight line to you? It looks like a straight line to me. So let's make our straight line right through it, going all the way up with an arrow on the end. And here we just want an arrow on the end going up. We don't want an arrow on this bottom one, because that would imply that we have less than $100, and that's never the case. We started at 0. We're going up and up and up from 100, just like that. So on any other normal problem, this line would have a slope of 1, because we rose 1 and ran 1. But here the context is different. My slope is 50. Because every box going up is worth $50. Now, an additional question. How much money is in the account after 10 months? Let's look at the graph. Where do you see 10 months on this graph? On the x-axis. We did this a lot with an Alex assignment, I remembered, because I explained it 40,000 times. We go up, 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 up. We hit the line, and then we look where? Over, 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 over to the y-axis. Where do I land up there? 600. So that tells me in 10 months of saving $50 a month, plus that 100 I started with, now I've got $600 in my account. That's one way to find it, just looking on the graph. Another way we can find it that might be easier for some of you is we take the equation y equals 50x plus 100. I'm going to take out the x and plug in 10 months. Right? I'm saving $50 a month for 10 months. Well, what's 50 times 10? 500. So I myself have put away $50 every month for 10 months. But how much did I start with in the account? Whoa. I started with 100. So that starting amount plus the money I've put in over 10 months gives me a grand total of what's 500 plus 100? 600. Look at that. Same number we found on the graph. We can do it either way. I don't care which way you do it. Mathematically by plugging it in, or graphically just by looking. Now sometimes we won't have space on the graph to look. If I ask you how much money you have after 20 months, right? There is no 20 months on here. So I would have to use the equation. So it's good for us to know both. All right? So when we get our test on Monday, I'm going to let you know right now, because half of you probably aren't listening anyway. This right here is question number 10. The last question on the test is this right here. Okay? Does that make sense? No, the numbers are different, but it's going to give you an equation, a blank graph. You've got to interpret what these numbers mean. You've got to plot the B, do the M, make your line, and answer the question, how much money's in the account after blank months. It'll be a different number of months. It'll be a different amount saved. It'll be a different money you start with. But the idea is the exact same. All right? So, did I mess up? Somehow I did. Go ahead and turn to the second page that we've already got glued in. And this is going to be much easier, I hope. I don't know how I did that. So we've been training for, yeah.
We didn't get second papers.
You didn't get the second paper? Is there any other group that didn't get the second paper? No? Okay. Just give me 1 sec. No, I got it. Thank you. So if you remember, we've been training. Every time we see a table, what do we do to the table? What do we put on it?
Arrow.
Arrows. Thank you. I'm glad you remember. So, rate of change is just another fancy way of saying unit rate, which is another fancy way of saying slope. These are all the same thing. Right? If I say hello, hola, and bonjour, they all mean the same thing. I'm just saying them in a different way. So unit rate, rate of change, slope, same idea. And we've got these two new terms here that we're going to be talking about. The first term is constant. Everybody say constant. Constant. What does constant mean? Consistent, repeating over and over again. If your little brother is constantly annoying you, he's doing it all the time. Over and over and over again, right? Good morning, Arlie. And then we have this other term, variable. What does variable mean? Thank you. Variable. What does variable mean? Well, if I have the variable x, and I asked you what is x equal to, what would your answer be? 1? It could be 1. Could it also be 2?
Yeah.
Could it also be 3?
Yeah.
X could be anything because x is a variable. So another word for this would be different. right? So constant means the same, repeating, repeating, repeating. Variable means different. So underneath constant, we're going to write same. Variable means different. I'm just going to put diff. So when I've got a table and it's asking me, hey, is this a constant or a variable rate of change? It's asking me, are my little arrows the same number or are they different numbers? Let's look at this first one. I'm talking about number of push-ups in an amount of seconds, right? I've got my table. I'm going to do my arrows. How would I get from 6 to 12 push-ups? What's that a change of? Plus 6, thank you. What about from 12 to 18? Plus 6. On the top, my time in seconds, how would I get from 5 to 10? Plus 5. And what about from 10 to 15? Plus 5. Do I have the same change in push-ups on the bottom? Yes, plus 6, plus 6. Do I have the same change in seconds up on the top?
Yeah.
Yeah, plus 5, plus 5. This is constant. Table A has a constant change. But what about table B? How would I get from 4 to 7 push-ups on table B? Plus 3. What about from 7 to 12? Plus 5. Good morning. Plus 5. How's it going? I'm going to have you sit right behind Keyshawn. Keyshawn, raise your hand for me real quick. And then I'll come talk to you in just a minute, okay? On the top, how do I get from 5 to 10 and 10 to 15, though? Plus 5, plus 5. So what do we notice about my push-ups down here? It's not constant. It's different. It's variable. So this person doing push-ups, right? They're kind of starting off slow, only 3 push-ups, and then they kind of pick it up. Now they got 5 push-ups. They're not doing it at a constant speed. It's variable. So table B has a variable change. It's different. This first person in table A is doing 6 push-ups every 5 seconds, constantly. Not slowing down, not speeding up. Nice constant speed. The second person is starting off slow, then kind of speeding up. Who knows, maybe they'll slow back down again. Not a constant speed. All right? So all you're looking for is the different numbers. Either 2 different numbers on the top or 2 different numbers on the bottom. That's what you're looking for. Does that kind of make sense? We've kind of done this already, right? I forget what lesson it was, but we definitely did this already. Yeah, look. Plus 4, plus 2, plus 1, plus 1. That means I can't find a K value. It's the same logic we're talking about right now. So you've got 4 tables down here. Take 4 minutes and see if you can identify whether each table is constant or variable. Do your arrows. Look for same numbers or different numbers. See if you can come up with 4 answers in 4 minutes before we start talking about it. them in here for you. If you just want them for fun, but I don't want you here in the room. Yeah. So while we're finishing up these, just read through all this stuff.
And labels.
Just goes over time.
You used to say gasoline and labels.
These two are variables and these two are constants.
Take a couple minutes, read through it, see if you have any questions.
It's a Monday.
Good. Okay. You guys get all 4 of them done? Yeah? Perfect. Say that one more time, bud.
I'm just writing constant.
But you did the arrows already? Perfect. That's great. So let's take a look. Number 1. What's the context that I'm talking about in number 1? If I were to find a unit rate, what would the units of my unit rate be? Yeah, hot dogs per minute. Right? Y over X, hot dogs per minute. I'm going to do my little arrows. How do I get from 1 to 3 on the top?
+2.
+2. What about 3 to 5?
+2.
So far, so good. But we got to check the bottom. How do I get from 4 to 12?
+8.
And from 12 to 20? +8. Give me a thumbs up, constant. Give me a thumbs down, variable. What do you think this one is? Yes, definitely constant. This is constant. Now, bonus question. What would my unit rate here be?
Oh.
Amari, you got it? No?
Wait, which one? No.
This first one. What would my unit rate be? Billy? 8 over, Kylie? Was that? 8 over 4?
8 over 2.
8 over 2, which is 4, right? I think that's what you were getting at. 4 what? 4 miles per hour?
For hot dogs per minute.
Hot dogs per minute. Hot dogs per minute. That is a lot of hot dogs in 1 minute. Anyone watch like the hot dog eating contest
No.
on 4th of July?
Yes.
I did.
That's
Pretty interesting stuff.
No, that's gross.
That's your opinion. So that one's constant. Let's look at the second one. Across the top, what's my change from 1 to 2 and 2 to 3? +1, +1. So far, so good. This must be constant, right?
No. No. Not yet.
Okay, let's check the laps. How do I get from 12 to 20? What about from 20 to 24? Ooh. Okay, so because my number of laps is different, this one is variable. Right? So what's my unit rate here? You don't have one. That's right. So this person did 8 laps in 1 hour. Then they did 4 laps in 1 hour. They got much, much slower in that second hour, right? They are not moving at a constant rate. I cannot find a unit rate. They're not moving at a constant speed, so I can't find a unit rate. Down here on the bottom, my jumps. How do I get from 0 to 10? +10. What about from 10 to 30?
+20.
+20. That's all right. On the bottom, I've got +10 and +30. That's definitely not working out. That would be variable. Welcome back. Look, I just saw you. Go ahead. And last one, weeks from 2 to 4. How do I get from 2 to 4?
+2.
What about from 4 to 6?
+2.
Thank you. On the bottom, number of shirts sold from 18 to 26 is +8. 26 to 34 is +8. Constant or variable for this last one? Constant. What's my unit rate here then?
8 over 2.
8 over 2, which simplifies to what?
4.
For what?
Unit
Per week.
4 shirts per week. Okay, the student store is selling 4 shirts per week. All right.